So here we have basically a 100-pound propane tank, 50 kilos. A 50-kilo tank is a good about 4 feet high, about 1 foot in diameter, and you probably will want to have 2 tanks connected with the dual propane connector hose. We'll show you that connection in just a moment. Here we have a regulator which takes the pressure from the tank and reduces it to 10 psi, pounds per square inch. We could go to a lower pound per square inch. We have a regulator that'll take it to 2 pounds per square inch. But before you start to change any of this, depending on what you find, for example, in Japan, please contact us so that we can guide you to the correct equipment. But for the moment, we prefer that you use this 10 psi, especially where we're going to be heating a 40-foot container with vehicles. This, when you start your service, we open this valve all the way. This isn't what we control the fuel flow with. This is just open it up and it comes over here to our heater. And the heater right here, we have a quick disconnect and we have it connected, and the valve that really controls the temperature is what we call the Regal Valve, which turn to the left and it opens it wider, turn to the right and it closes it. So this is more fuel, higher temperature, less fuel, lower temperature. And you can mark, we have what we call a digital thermometer here that will measure the heat coming out the end of the heater. As you can see, we don't have it on currently just because of a noise factor, but this is where we do. So I can control my temperature right here with this Regal valve, okay? Now, a device that we have added that we think will improve the efficacy of this whole treatment process is a Y connector on the intake manifold. So right behind here is where the air comes in and goes into a fan that then through a burner and then out the ducting. So we have placed ducting on either side of the shipping container. And hopefully you can see this. As you see right here, we have one, and this is basically 8 feet wide, right to here, right to the edge of this. And so we're using kind of a mock-up situation, but you do not want to cover the space below this ducting. It doesn't even have to rest on the ducting if you don't want, but you've got to let some of that pressure out, otherwise you'll get back pressure and your heater will shut down. With this methodology, you are drawing heated air out, first forcing it. So let's get this point. I'm coming in at 5,000 CFM right through the end of this barrel and into this ducting. Do I need to use ducting? Not necessarily. You could snug this right up to the door and you could then turn it on and not use this third piece of ducting. What does this piece of ducting do for us? Well, it drops it down to ground level, where in the case we're heating autos, it might be a good idea to be able to keep it low at first, then it will rise up through the frame of the auto and continue to the very end of the shipping container. And so you do get an advantage dropping this down. But you know, we're talking about 6 or 8 inches. You could just bring this right in and not mess with this piece of equipment. Okay. Now your shipping container may have swinging doors. It may have a roll-up door. In either case, you may have to do some modifications. The point is that you want to let, if this is a swinging door and you want to cover it with some sort of material, even a plywood that you built specifically to lock into place, you still wanted to keep it about 18 to 20 inches above the top of the ducting. And it could be sheets, it could be whatever material you do to fill that 8-foot roll-up door or swinging door, so that you have it. Because right now, this recirculation duct and this recirculation duct, which connects to the back side of this heater, will pull air out. It will allow an aggressive return and that elliptical vortex that we were talking about, as opposed to, say, in a structure for bed bugs, you go on a circular vortex. And so we're pulling air out of the sides, but you've got to have air circulation to drive the heat energy into the frame and the components of the car. Okay. Open the tank valve all the way so you have a good flow. Then come over here to your heater. I'd like to start by just doing the fan before I ignite the fuel. So here's the fan. I see that there's no flopping around of ducts. Everything seems to be working. Now, so you can hear me, I've turned the fan off. The next thing I'm going to do is I'm going to ignite the fan and fuel. And I'm going to turn the switch up, and then we'll start adjusting temperature by moving the Regal valve. So just observe us doing this. There'll be a little bit of the fan motor noise, and we won't talk through this. We'll just show you this is what we're doing, just to give you an example in this mock-up. You can also see that we've used a thermal blanket, which could be a fine curtain as long as you secure it at each corner, so that it doesn't start flopping around too much. But we've put that in to show you an example of something that's about 8 feet wide that would function as a barrier, forcing the air down, out low, including with these recirculation ducts. So here we go with igniting the fan, the heater. What we have done now in this mock-up structure is we have eliminated the middle ducting. This gives you an option. You can either have it, you could theoretically put a little diffuser on the front if you want to force it down, some physical attachment, or you could just let it run through. It all depends on what you're hitting and how your airflow goes, and you can adjust to that end. But for this purpose now, we're showing you without that middle duct that we showed you previously. So you can go with or without it. Now I'm going ahead and turning the Regal valve to the right. You see the temperature coming down? So I want to shoot for temperatures probably, it just depends on, but 180, we're trying to achieve, for regulation purposes, I believe it's 140 degrees Fahrenheit for 15 minutes, I believe is the specification that is being made. So we can use temperatures slightly higher here. I could go with another turn and drop this down into the 180s, which I think is plenty. Now you can see that I turned it a little bit too far, so we'll come back up and we'll get it. This is normal stuff. You can fine tune it till you have it right at the spot where you feel the best.